Oh gosh. Hold on, let me get that. So in this lesson, I'm going to quickly detail some information about representative particles. I did this differently last year with my gifted kids, and it went really well. I think it helped to enhance their understanding of basic vocabulary, even more so than my AP kids last year, because I think they just didn't understand. So definitely something I'm going to continue. So let's look at representative particles, right? This is related to like Avogadro's number sort of thing, okay? I'm going to go to my little handy dandy whiteboard, all right? And here we are, once again. Gotta be mindful of my time because I do have a class coming up soon. And just not having a good day today, guys. Okay, scoot over. So right, we know that 1 mole of anything is equal to 6.02 times 10 to the 23rd particles of that substance, right? So when I say the word representative particles, what I mean is particles of that substance. That's what we mean by representative particles, okay? Now, so what are our representative particles? Well, it depends on the type of substance we're referring to, right? It depends. So let's look at some different types of substances and see what those representative particles might be. I'm sorry about my phone, guys. It's just on swole since the beginning of school. All right, well, if we are talking about an element, right, such as zinc or gold or, any of them, sodium, well, those are made up of atoms, right? The atoms themselves are made up of subatomic particles, okay? And I think you would know that, right? So the representative particle of an element, such as these guys, is an atom. The representative particles of atoms are your subatomic particles, is your protons, neutrons, and electrons. And yes, there are more, but these are the main players for our concerns. Okay, hopefully you don't have any questions about that. Well, what if it's not an element? Maybe it is an ion. Well, no, let's go like this. Maybe it's an atom of an element. Atom. Well, that's right there. Atom of an element. That's right there. And if we have ions, monatomic particularly, monatomic ions, such as the silver ion, the sodium ion, the oxide ion, the sulfide ion, the nitride ion. Well, what are these ions composed of? They are composed of subatomic particles, right? Just like atoms are composed of subatomic particles, ions are also composed of subatomic particles. Okay, now that's may seem weird, but it's really pretty straightforward, right? Atoms and ions are made up of subatomic particles. Elements are made up of atoms. Okay, let's go a little bit further. Now, what if we have a polyatomic ion and not a monatomic ion, right? If we have a polyatomic ion, well, that would be like ammonium or phosphate, right? Or cyanide, right? Well, these guys themselves are composed of elements. More particularly, They are composed of atoms. They are not composed of ions. In here, I have one nitrogen atom, and I have 4 hydrogen atoms. Okay, and they are chemically bonded together, and they have lost an electron. So in one polyatomic ion, not 1 mole, in 1 ion, I have atoms, 1 of which is of nitrogen and 4 of which is of hydrogen, and they are chemically bonded in a covalent manner. However, they have lost an electron. If I have a formula or a molecule of phosphate, 1 molecule of phosphate, or 1 molecule of phosphate, I have 1 phosphorus ion. Nope, that's so wrong. 1 phosphorus atom bonded to 4 oxygen atoms, and that would be a covalent bond because these are nonmetals. And they themselves have gained 3 electrons, but they are a unit. That unit would be called a molecule. Actually, that's wrong. I'm going to get rid of this word. That unit is called a polyatomic ion, right? It's not called a molecule because molecules are neutral. So that was actually incorrect, and you need to erase that. In 1 polyatomic ion of ammonium, I have 1 nitrogen atom and 4 hydrogen atoms. In 1 polyatomic ion of phosphate, I have 1 phosphorus atom and 4 oxygen atoms. They themselves are chemically bonded with a covalent bond, and the whole thing has gained 3 electrons. I'm not going to do cyanide. It's got 1 carbon atom and 1 nitrogen atom. Okay? Now, let's talk about our compounds. We kind of just did. Let's say that we have an ionic compound. Well, an individual ionic compound is referred to as a formula unit. So the particles of ionic compounds are called formula units, such as NaCl. Each individual NaCl is referred to as a formula unit. In a covalent compound, which includes acids here, okay, such as carbon dioxide, I call these molecules, all right? So that the representative particle of a covalent compound is a molecule, okay? I call individual ionic compounds formula units. I call individual covalent compounds molecules. What I did last year and we're doing now is we're taking it 1 step further. What is this formula unit of sodium chloride then composed of? What are the particles of that substance? One of these contains ions, right? I have 1 sodium ion. It's not an atom, it is an ion. It is charged, it has lost its electron, and I have 1 chloride ion, okay? Now from a covalent compounds are not composed of ions. No one has gained or lost electrons. They are composed of atoms that are bonded together by sharing their electrons. Whereas ionic compounds are composed of ions that are bonded together by the attraction of the positive to the negative. So in the ionic compound, we have ions. The covalent compound, rather, is not composed of ions. We did not deal with charges and charged particles. We're simply sharing those electrons so that these molecules, one molecule, it'll look like this, right? I can draw this one. I can't really draw those formula units too well. Oops, is composed, as you see, of one carbon atom. Here we have an ion. Here we have an ion. Here we have an atom. And two oxygen atoms. But they are not ions. So it would not make sense to say how many oxygen or oxide, rather, ions are in carbon dioxide. But it would make sense to say how many chloride ions are in sodium chloride. It would not make sense to say how many chlorine atoms are in sodium chloride, because there are no chlorine atoms. There are only chloride ions. It does not make sense to say how many sodium atoms. There are no sodium atoms. There are only sodium ions. And then the opposite is true down here. It does not make sense to say how many oxide ions. There are no ions. There are atoms. And there is a carbon atom, but there is no carbon ion here. And that's about it, guys. About it, okay? So you might have some questions. I know last year students had a lot of questions, and I remember my cute girls, they were really confused, but they definitely figured it out. So you can too. And just figure out what those questions are so that then you can bring them to me and I can help you better. All right? Peace out.